The following presentation introduces Sveltos, a lightweight application for managing Kubernetes clusters. Today, it's very common for organizations to run and manage multiple Kubernetes clusters across different cloud providers or infrastructures. With an increasing number of clusters, consistently managing Kubernetes add-ons is not an easy task. Sveltos is a lightweight application designed to manage hundreds of clusters. Sveltos provides declarative API to deploy Kubernetes add-ons across a set of clusters. Sveltos has built-in support for Cluster API-powered clusters. This means that if Sveltos is deployed in a management cluster with Cluster API, no action needs to be taken for Sveltos to manage add-ons on Cluster API-powered clusters. Any other cluster GKE, for example, can be easily registered with Sveltos. After that, Sveltos can manage Kubernetes add-ons on all the clusters seamlessly. Cluster Profile is the CRD introduced by Sveltos to allow admin to express its intent. Cluster Selector field is a Kubernetes label selector. It selects a set of clusters where add-ons need to be deployed. Helm Charts field contains a set of Helm charts that will be deployed on all clusters matching the cluster selector. In this example, we have Sveltos running in the management cluster and we have two workload clusters. The admin is requesting the Kyverno Helm chart to be deployed on all clusters matching the label selector env equals production. If the label env production is added to both clusters, Sveltos detects that these two clusters are now a match for the cluster profile. Because of that, Sveltos starts deploying all listed Helm charts on those two clusters. Kyverno gets provisioned on both workload clusters. Helm chart values can be defined as templates. Such template instantiation happens at the time of deployment, reading values from the management cluster. In this example, when deploying Calico in a matching workload cluster, the pod address pool is taken from the cluster instance. Configuration drift is a common term to describe a change that takes place in an environment. Drift is an issue because it causes systems and parts of a system that are supposed to be consistent to become inconsistent and unpredictable. In this case, the configuration drift is the change of a resource deployed by Sveltos in one of the managed clusters. Sveltos monitors the state of the managed clusters, and when it detects a configuration drift for one of the resources deployed, it resyncs the cluster state back to the state described in the management cluster. In this example, Kyverno Helm chart was provisioned. Then, in one of the workload clusters, a command is executed deleting the Kyverno deployment. As soon as the delete command is executed, Kyverno deployment disappears from the workload cluster. Sveltos detects this change, and it reconciles again, immediately reprovisioning Kyverno to the workload cluster. Sveltos can also be configured to automatically update cluster labels based on the cluster runtime state. The core idea of Sveltos is to give users the ability to programmatically decide which add-ons should be deployed where by utilizing a cluster selector that selects all clusters with labels matching the selector. Sometimes the versions of required add-ons depend on the cluster runtime state. For instance, when a cluster is upgraded, some add-ons need to be upgraded as well. In such cases, it is convenient to instruct Sveltos to manage cluster labels so that when a cluster runtime state changes, the cluster labels are automatically updated. And when the cluster labels change, cluster profile instances matched by a cluster also change. Since the cluster starts matching new cluster profile instances, a new set of add-ons is deployed. In this example, we have two workload clusters running Kubernetes version v1.24.2. The admin posts a cluster profile requiring Gatekeeper to be deployed on all clusters with label Gatekeeper version 3.9. The admin also posts a classifier. The classifier matches clusters with Kubernetes version higher than v1.24.2 and strictly less than v1.25.0. Classifier indicates that Gatekeeper v3.9 label needs to be added to each cluster matching this classifier instance. Because both workload clusters are running Kubernetes version v1.24.2, they both match the classifier. Since both clusters match the classifier instance, the label Gatekeeper v3.9 is added by Sveltos to both clusters. As soon as this new label is added, both clusters start matching the cluster profile, and the Gatekeeper Helm chart is provisioned. Admin now posts another classifier matching any cluster with Kubernetes version higher than or equal to v1.25.0. As soon as one of the workload clusters gets upgraded to Kubernetes version v1.25.2, the cluster starts matching the new classifier instance and stops matching the old classifier instance. Sveltos updates the cluster label as instructed in the new classifier instance. When the cluster label changes, it starts matching the new cluster profile, and the Gatekeeper Helm chart gets upgraded. The snapshot feature allows capturing complete Sveltos policy configurations at an instant in time. Using snapshots from different timestamps, it is possible to see what configuration changes occurred between two snapshots and revert policy configurations to any saved configuration snapshots. Operations using snapshots, such as capture, diff, and rollback, are performed with the Sveltos command line interface. Rollback is a feature in which a previous configuration snapshot is used to replace the current configuration deployed by Sveltos. Please use these links for more information, and thank you for your interest in Sveltos.